Hey guys, welcome to the multiplying and dividing rational numbers quick check. Okay, so on this, we're going to use this same situation over and over and over again. I'm going to go ahead and kind of color code it just to make my life a little bit easier. It says Carol is baking cookies and needs 2 1/4 cups of flour. She needs 2/3 cup of white sugar. She needs 1/4 cup of brown sugar and 1/16 cup of baking soda. We're going to use this information to answer the following questions. So the first question says, divide the amount of white sugar by the amount of brown sugar. And what is the quotient? Okay, so we know that when we divide, we're going to set them up as a fraction. So I'm going to start off, and this is going to look weird first, but I'm going to take my white sugar, which is 2/3, and I'm going to divide that. So I'm going to do this big fraction line by brown sugar, which is 1/4. Now that might not look like how you're used to seeing it. You might think that it should be written like this, and either way is fine. But I do want you to know that it can be written. A fraction can be divided by another fraction with this giant fraction bar. And what I'm going to do is I'm going to use the calculator because I just need to be very proficient with my technology. So I'm going to do 2/3 divided by 1/4 in my calculator. But please, 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 please remember, when you do it in the calculator, you have to put each fraction in its own parentheses. So let's go to the calculator and see what that looks like. We're doing parentheses 2 divided by 3, and then we're going to close our parentheses. And we're going to divide that by another fraction. So I'm using parentheses again, and I just forgot what it was, 1/4. So I'm going to do I need to be back down here on the bottom. I'm going to do 1 divided by 4, and then I'm going to close that parentheses. And now notice we have a fraction divided by a fraction. It gives us a decimal answer, and we don't want our answer as a decimal, so we're going to go over here and we're going to hit this convert to fraction button. And this tells me that it's 8/3. Actually, I'm going to write down all the ways we could write our answer. It could be 2.67 if we round it, or 8/3. Let's write down all these options. This equals 2.67 cups, or it equals 8/3 cups, or we can convert that to a proper fraction. We can say how many times does 8 go into 3? So we would count by 3, 3, 6, 9. 9's too big, so it goes in twice. 3 goes into 8 twice, which is 6, and it has 2 as a remainder. So these are the 3 different ways you could write it. You could write it as a decimal, as a proper fraction, improper fraction, or as a proper fraction. Let's check out the next one. Same problem. This time it says if the amount of white sugar is increased by a factor of 2.5 in cups, how much white sugar would there be? Okay, so if we think about the word increase, we are making it bigger, right? We're going up, so we need to be adding. So if we start off with our regular white sugar, we're dealing with white sugar here, and we want to increase it by 2.5 cups, how much white sugar would there be? Y'all, I just realized I read this problem wrong. It doesn't say we're increasing by 2.5 cups. It says we're increasing by a factor of 2.5. That was a reading error on my part. That does make a difference. Oops, thought I had the eraser. Instead of adding, we're going to be multiplying because we're increasing by a factor of 2.5. So we want to make this 2.5 times bigger, which is another way of saying it. So we're going to take 2/3 and make it 2.5 times bigger. So we're going to do 2/3 times 2 1/2. Now again, I'm going to do this in my calculator, but when I do it in the calculator, I'm not going to put this proper fraction in. I need to go ahead and convert that to an improper fraction. So we did this the other day. You multiply the denominator times the big number, and then you add in the top number to get the numerator. So that's a lot of math words, but 2 times 2 is 4, plus 1 is 5. So if I convert this, I would have 5/2. We always keep the regular denominator the same. So I can type this in my calculator, and remember, each fraction gets its own parentheses. So I'm going to go to my calculator, and I'm going to type 2/3 times 5/2. So parentheses, 2 divided by 3, close my parentheses, times parentheses, 5 divided by 2, close my parentheses. Now remember, we can write the answer in a bunch of different ways. It could be written as this, 1.67. We can convert it. It can be written as 5 over 3, or we can make it a proper fraction. So let's look at all of those. I'm going to write all these down. 1.67, 5 over 3. Now, when we convert it to a proper fraction, remember we're asking ourselves, how many times does 3 go into 5? 3 goes into 5 one time. There are 2 left over. So I get 1 2/3. If I take this original amount of flour and I increase it by a factor, which means I'm multiplying by 2 1/2, I end up with 1 2/3 cup. Let's check out the next one. Same problem, but down here it says, if the flour were increased by a factor of 2 1/2 in cups, how much flour would there be? So again, we're increasing it, so we know we're making it bigger, and we're increasing it by a factor of 2 1/2, so we're going to be multiplying by 2 1/2. So let's start off with our original flour, which is 2 1/4 cup. So I'm going to take 2 1/4, and I'm going to multiply that by 2 1/2. And I'm still going to go ahead and use my calculator, but first I'm going to convert them to improper fractions. 2 times 4 is 8, plus 1 is 9, so that one would become 9 over 4. 2 times 2 is 4, plus 1 would be 5. This one will become 5 over 2. And I'm going to multiply those in my calculator with parentheses. So, parentheses, 9 divided by 4, close parentheses, times, I just forgot what it was, 5 over 2. Oops, let me get back in there. 5 divided by 2. So we have a couple different ways we could write our answer. It could be 5.625. It could be 45 over 8. Let's write both of those down. What's happening? Y'all, I am sorry about that. My stuff was all going crazy and freezing up, so I had to pause the recording for a minute. But we did just type it into our calculator, and it told us it's either 5.625 cups, or 45 over 8 cups, or 5 5/8 cup. So let's go on to the next one. If only 1/4 the amount of brown sugar in the recipe were used, how much brown sugar would be used? Okay, we're not using the full amount of brown sugar. We're just using 1/4 the amount. So in other words, 1/4 of the amount. So you can think of this two different ways. I'm still going to think of it as like we're multiplying it by a factor of 1/4. I want 1/4 of the amount of the original. So my original was 1/4, and I'm going to multiply that by a factor of 1/4 because I'm only going to use 1/4 of the whole recipe. Now, I wanted to show you, I've been typing all these in the calculator, which you can absolutely still do, but also I just wanted to mention that if they're both in this fraction form, you can just multiply straight across. For some of you, that's going to be a lot faster than typing in the calculator. So 1 times 1 is 1, 4 times 4 is 16. Let me go back. I should have shown you that on all these. Like if I would have gone right here and I would have multiplied straight across. 9 times 5 is 45. 4 times 2 is 8. So you could have gotten this answer without typing it in Desmos. You could have just multiplied straight across. So you have options on how you want to solve these. I tend to use the calculator just to double check my work, but I wanted to show you that you can also just multiply straight across. So if we are using 1/4 the amount of original brown sugar, then we would have 1/16 that we're using. Okay, if only 1/4 of the amount of baking soda in the recipe were used, how much baking soda would be used? So we start off with 1/16 cup, and we want to multiply that by a factor of 1/4. You could also, I should mention this, you could also say if we're using only 1/4 the amount, it's basically the same as dividing by 4. So you could take your fraction 1/16 and divide it by 4. That's the same thing as multiplying by 1/4. So either way you want to set it up, I tend to just multiply. Now you could type it in decimals or you can multiply straight across, and I will show you both. 1 times 1 is 1. 16 times 4 is, I don't even know. This is why I should use a calculator. 64. But let me go and double check that in the calculator because I don't really trust myself. Why is it doing that? This is what it was doing earlier. Kept freezing on me. Okay. So we were typing in 1/4, closing our parentheses. Whoa, not like that. 1 divided by 4. What is it going crazy for? Times, oh man, didn't I already forget? Times 1/16. Okay. All right, and if I do that in my calculator, it does give me 1/64, which is what I got with my brain. Oh, not again. Sorry, y'all. Hang on just a second. Okay, I made it back to our lesson. The last one says, which area model correctly represents the expression 2/3 times 1/4 plus 3/5? So what's really going on here is you could either add the fraction first and then multiply it by 2/3, or you could distribute. But it wants you to pick out the correct area model. Now, if you look at all these area models, this says that we're multiplying here and we're multiplying there. That's not what we're doing. If we look at our question, it says that we're doing 1/4 plus 3/5. So even if you don't understand area models at all, like you could look at this and be like, what is happening? The only way that this works is either if you distribute and you say 2/3 times 1/4 plus 2/3 times 3/5, you could distribute, or you could go ahead and add the fraction and then multiply it. But on each of these, you're not distributing correctly. The only thing that works here is this one, because we're adding the 1/4 plus 3/5, and then we're going to multiply it by the 2/3. And if you filled in each square, this first square would be 2/3 times 1/4, and then this square would be 2/3 times 3/5. So this is the correct area model because you have to multiply it by each of those. All right, guys, good luck on your quick check.